Hello everyone. In this video, I'm going to discuss the derivatives of exponential function. So if you have to find the derivative of e raised to power u with respect to x, so it would be e raised to power u, and then by chain rule, since we have u here and we have x here, so we need to use du over dx. So we have to apply the chain rule. Or if you have just the derivative of e raised to power x, so that would be just the exponential function itself. And since here if you just do dx over dx, that is just 1. So derivative of e raised to power x with respect to x is just same function e raised to power x. Let's do few examples. Oh, before that, I would also like to point out, so if you have any other exponential function, let's say if you don't have base e, but you have a base a, so what is the derivative of a raised to power x? So that would be a raised to power x times ln a. So we just have one additional factor ln a when we have base other than e. So for the first example, let's say we have y is equal to e raised to power 2x plus 5 raised to power 6. Find the first derivative. So again, so first we take the derivative of outside. So in this case, the outside function is the exponential function. So derivative of exponential function is the function itself. And then by chain rule, since this is not x, we have some other expression in place of x. So we need to take the derivative of this power. So derivative of 2x plus 5 whole thing raised to power 6 with respect to x. And then e raised to power 2x plus 5 raised to power 6 as it is. So here first we use the power rule. So bring the power down, reduce the power by 1, and then by chain rule again we need to take the derivative of inside. So we have to use the chain rule repeatedly in this example. So e raised to power 2x plus 5 raised to power 6. 6 times 2x plus 5 whole thing raised to power 5, and then derivative of 2x is just 2, derivative of 5 is 0, so we just have 2 here. So overall we get, so the derivative is, so 2 times 6 is 12, so 12 times 2x plus 5 raised to power 5 and e raised to power 2x plus 5 whole thing raised to power 6. So that is our derivative of the given function. Let's try one more example. So let's say we need to find the derivative of a function which is given to us. So function is x cube e raised to power x, and find first derivative of this. So in this case, so we can see that we have product of two factors. So we need to use product rule. So in this case, the derivative would be first function as it is, derivative of second, which is just e raised to power x, plus second function as it is, derivative of first, and derivative of x cube would be 3x square. So overall, we can see that x square is a common factor, e raised to power x is a common factor. So in the first term, we are left with x, and in the second term, we are left with 3. So this is good enough. So that is our final result. Let's try a couple of application problems. So in this one, first example, we need to find the slope of tangent to the curve where x is equal to 1.275. So when we learned about the derivatives, so we learned that y dash or dy over dx is the equation for slope of tangent at any point x. And if we plug in this particular value of x in that, so then we get the slope of tangent at that point. So in this case, we're going to plug in x equals to 1.275. So our first goal is to find the first derivative. So the first derivative of our given equation would be, so derivative of 3 e raised to power 2x over x squared plus 1 with respect to x. So in this one, we need to apply quotient rule. So quotient rule, because we have u over v form. So the derivative of u over v is, so denominator square. So denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator. So we're going to use this result here now. So we get, so x square plus 1, so denominator square, then denominator as it is, derivative of numerator. So derivative of 3 times e raised to power 2x, so that would be 3 as it is, e raised to power 2x times 2, because we need to apply chain rule, minus 3 times e raised to power 2x as it is, and the derivative of denominator. So derivative of x square plus 1, that would be 2x. So we get 6 e raised to power 2x, x square plus 1 minus 6x e raised to power 2x on the top, and x square plus 1 whole square in the denominator. So now we can take some common factors out. So we get, so 6 e raised to power 2x are the common factors. So inside we are left with x square plus 1 and just x in the second term, and this is what our derivative is. But we want to find the slope of tangent at when x equals to 1.275. So at x equals to 1.275, so we simply gonna plug in the values now. So our slope at this point becomes, so 6 e raised to power 2 times 1.275, so 1.275 square plus 1 minus 1.275, and similarly we're gonna plug in that value in the denominator, and when you solve it using the calculator, so we get approximately 15.05. So therefore what we found is that the slope of tangent, so slope of tangent at x equals to 1.275 is 15.05, and this is what we were looking for. Let's do one more word problem. So pause this video and read the next problem carefully. The temperature T of a thermometer as a function of time, so where T is the time in minutes, after the removal from a freezer is given by T equals to this equation. So we are given this equation that T is equal to 8 times 3 minus 5 e raised to power negative 0.50 T. How fast is the temperature changing when T equal to 6 minutes? So how fast is the temperature changing? It means we need to find dt over, so dt of temperature over d small t, so rate of change of temperature. So let's start with taking the derivative with respect to t on both sides. So 8 as it is, it's our constant coefficient, and so derivative of 3, so derivative of a constant inside, so that's going to be 0, minus 5 as it is, and derivative of e raised to power negative 0.5 t. So exponential function derivative as it is, but by chain rule you need to take the derivative of the power, so that is negative 0.50. So we get 8 times, so 5 times 0.50, so that is 2.5, and negative time negative is positive, and e raised to power negative 0.50 t. So this is our derivative, and overall we get 20 e raised to power negative 0.50 t. So this is our change in temperature, rate of change of temperature. But we want to find when, what is this change when t is 6 minutes. So basically this is our t dash. So we are interested in finding t dash when time is 6 minutes. So just put t equals to 6, So 20 e raised to power negative 0.50 times 6. And when we solve it, we find that it is approximately 0.996 degree Celsius per minute. So that is our rate of change, or if you want to give in the same sig figs as in the question, so 1.0 degrees Celsius per minute. So this is the rate of change of temperature. So if you're wondering, you could have done the same question in other way. So second method is, how could you have figured out the derivative? So our original function is 8 times 3. So you can expand this to start with. So 8 times 3 is 24 and 5 times 8 is 40. So you could have expanded the given function, and then from here we got, so t is equal to, okay, so dt over dt is equal to, so derivative of 24 is 0. So negative 40 e raised to power negative 0.50 t times, by chain rule, negative 0.50, and then again, so negative negative positive, so we get 20 e raised to power negative 0.50 t. So we get the same derivative here and here, and then in the end you just plug in the value and you get 1.0 degree Celsius per minute. So no matter what you do, you get the same answer in the end. So this was the other approach that you could have used to solve this problem. So basically the gist of this video is that derivative of exponential function, if the base is e, so e raised to power x is the same function itself. I hope that makes sense. If you like this video, please subscribe to my channel. So in the next video, I'll start with our integration topic. See you next time. Thanks for watching.